Yeah, welcome to our meeting, Digitalization through a Bottom-up Approach, or how to generate added value for brownfield plants. My name is Willem Otten. I'm giving the presentation together with my colleague Kai Dade from Process Technology and Engineering, Evonik Operations. Yeah, first of all, let me briefly introduce Evonik. In a nutshell, 13 billion sales. Actually, we are a very technology-oriented company. 80% of our sales are generated in leading market positions, and these leading market positions are very often based on technology. We have more than 30,000 employees, and we also invest a lot of money, nearly 1 billion every year. Process Technology and Engineering is a global organization with 900 experts around the globe dealing with technology, process development, engineering, and process and plant optimization. So we are as well in the early phases of the asset life cycle as in the operations. I'm also a member of the board of NAMO. NAMO is an international association dealing with automation technology, with users of automation technology. So, understand your business processes. What we have seen are a lot of initiatives actually failing, having investing a lot of effort and generating little added value. And on the other hand, we have a huge, in the process industry, we have a huge installed basis. So the question is how to generate added value, and particularly in our existing plants. We have a simple business model. There are two major business processes. That's the supply chain from our raw products, raw material logistics, production, product logistic to our customer. That's the process where hopefully at the end we get money from the customer and earn the money. And on the other hand, we are still very asset intensive. I mentioned we are in Evonik usually invest 1 billion every year. So the product and asset life cycle is essential for the process industry. Starts with the product development based on the customer requirements, process development, engineering, construction, and then production, including maintenance. So that's the asset life cycle. So, and the third area is the production, and there we call it smart production or vertical integration, where we use the digitalization and automation technology to improve our core of the process sees the production. And whatever we do, digitalization must contribute to the transparency and efficiency in these main processes. So that's the major goal, either to improve the supply chain or the asset life cycle or the operation. Well, these are the major goals. You can go a little bit into detail, looking at the supply chain and the asset life cycle. It looks a little different in manufacturing industry and process industry, but these two basic business processes are quite similar. And we use, let's say, classical automation technology. You see the automation pyramid from the field level, the actors, sensors, controllers. DCS, APC stands for Advanced Process Control, Manufacturing Execution System, and ERP systems to run these processes. So Kai will introduce the methodology we apply to develop value-adding roadmaps.
Okay, so hello also from my side. As Willem already stated, We've seen many tools, many proof of concept projects, but how do we really gain value? So, and as always, we start with the, let's say, needs from the operations. So, and it's important to have as an input the strategy from plant or from the business lines, which then starts to invest and initiate digitalization projects. As always, you have to start with where are you at the moment. So we assess in a structured way the current digitalization state of the plants and the potential target state in order to have the digitalization measures right on spot for the needs of the business lines and plants. Afterwards, we implement roadmaps, and with many digitalization initiatives, it starts with it ends with a lighthouse project. Important is that we think that to the end and do also the implementation and also consider operation and continuous improvements. On the next slide, I will go a little bit into more details. Okay, so first of all, why do we do that? And different plants do have different needs. Some of them are striving for availability and plant uptime. Others are need to improve their process efficiency or energy efficiency. And so each plant has its different or individual needs. Then it's for sure, as already said, we need to know where we are and where we want to go. And with that, we also can see or calculate the business value and the potential of the digitalization measures, because we're not doing it only for the sake of using that technologies. And afterwards, for different purposes, we do have different technologies. So it's important to match the needs from the plant with the respective technologies. And in the end, we have a set of measures, but we have to do them in the right way. So that's we have to prioritize the different measures. And in the end, it's all about execution. So we have to bring or manage the digitalization project as any other project properly. All right, so the next point is maybe a little bit insight into the tools we are using. And I will start with the upper right side. So we have, and it's fairly known maturity levels in the industry. We say we have different, starting from basic computerization over connectivity, over visibility, transparency, up to fully automated and adaptive remote operation of plants. So these stages from 1 to 6, we do apply for the main focus areas of plant operation, and starts with process safety. That's the figure on the left-hand side. Process safety, quality management is an issue, also production management, logistics, but for sure also things like process automation and data management. So we use the grade or the rating from 1 till 6, apply that to these 9 fields and production. And there we say, okay, we have a current state and we have a target state. And it's not necessarily that we do have to bring the plant in all these 9 areas to the highest level, because some of the technologies are not yet available, and and it may be that it doesn't simply make sense to bring it to the higher or to the highest level due to the cost-benefit ratio. And in the bottom right side, we use the so-called technology trees that we say for each stage we do have proven technologies. And to give a quick example, if you think about advanced control or advanced analytics, yeah, you need to have the data and network infrastructure for sure. I mean, it's not hard to understand, but it gives a guidance to do the right thing at the right time. How do we do the assessments? That's, you can see on the next slide. So we have different developed tools. So the first one is we analyze the business process, because digitalization is about converting maybe manual processes into more digital process. So we analyze the business process. And I'll, on the next slide, there will be an example. We for sure use the technology trees to see what is already implemented in the plant. And we also have questionnaires to see where are the, let's say, the pain points of the people in the plant. And it's also, in this questionnaire, it's also about organizational, cultural shift of ways of working. And it's for sure, it's also, and there we do have sometimes, as any or many others also, the lack of resources, of qualified resources, is always an issue. So the questionnaire part is more a little bit fuzzy. And the important thing is why we do that in the plants is digitalization is nothing that comes from corporate center. We have to do that together with the people in the plant, that they accept the technology and the change in the way of working. On the next slide, you see the 6 stages. I would like to go a little bit deeper into that stages. And the first one is the computerization and connectivity. This is something where we have to, or one has to invest a lot, and this is just basic infrastructure. And then we say, okay, the third step is to see what is happening, having insights. And then if you just see it, then you can start to understand what has happened. And in the stage 3 and 4, mainly done with visual analytics stuff. And after that, you can do more sophisticated stuff. Like if you know where you are and if you know why you are at that specific point, then you can go into, okay, what will happen in the future? And for sure, in the last step, you can use the prediction of a future plant behavior to optimize that to a point where you would like to have your plant. All right, so and to give a more tangible example for that, we have chosen one on the next slide. It's about lab management because it's quite intuitive. Let's say if you go the original path, you take a sample point in the plant, go into your lab, and then make the analysis, and then write it down into your analog shift book. And with each step indicated by 1, 2, and so forth, you continuously digitize certain steps. So you can also enter it into your Excel spreadsheet. Then at least you have it computerized, but you don't have it available anywhere. And then, for instance, you can also put it into a central data or LIMS recording. And with each further step, once you have it there, you can use it for plant monitoring. You can use the values for your KPIs. And you can also use, for instance, online inline analytics, composition measurements for prediction of plant behavior. And in the end, you use it for automatic plant behavior. And these are very simple business processes here for a quality management. And we do have these business processes, also future ones, which are not yet implemented for all the 9 areas and the different steps there. Okay. As already said, the other important point is the technology tree. And here it's we have these technology trees also for all these nine areas. And you see, we mark the stuff we already have implemented in that specific plant. We see white spots where we do have to fill these gaps before we can go down the road and do the implementation for stage 3, 4, 5, and so on. And it doesn't make sense to think about measures on stage 5 and 6 right now if you have still too many holes in the stages 2 and 3. So that is, in a nutshell, very a simple example for our methodology. We have already applied that to almost 50 plants around the globe. So it works in different cultural regions and for different plants, both batch as well as large scale continuous plants. But in the end, what I said at the beginning, it's important to know the business case and the plant needs. So
Yeah.
I will hand now over back to Willem, and he'll
So
explain a bit about the different um, business needs.
yeah, after we have done the evaluation, we see where we are. And as Kai mentioned, the question now, where is the added value? And we are not only talking about money. That means, for example, process efficiency or asset availability. We are also talking about safety and compliance, and what becomes more and more important for our production is flexibility. So usually we have this catalog of objectives and discuss what are the main objectives for the plants. Then we have to choose the technology. I will not go into detail, just a few examples. We have physical supported technologies. For example, we use 3D printing for our car operators, assistant tools and things like that, and IT software tools. There's a variety of tools and new applications. Yeah, so we have to think about what is the appropriate technology to apply. I would like to give you one example which makes this a little bit transparent. Let's have a look at the maintenance process. And you see on the top the 6 levels of maturity, and you see the technology and the issues and benefits you may generate. Of course, the simplest process is to have a shift book, write something down, and have a handwritten order, or tell somebody on the telephone, okay, repair the pump. That's not an unusual process in our plants. But it's hard to document. Now it's intransparent. You cannot reuse information. So the next step is computerization. And the classical way to do is to have an Excel list. Yeah? Type down the problem in the Excel list, type down the work order, hand over the Excel list. So at least you can reuse the data, yeah, but it's still reactive process. Then the next step is connectivity, bringing this information together in one system. And the usual way to do it is, for example, using SAP PM, the plant maintenance module. So you have the data available, yeah, or everybody has access to the data, yeah, and you can implement the work process, defining the work order and working and fulfilling the work order in that system, but still reactive. So what we would like to do is to understand what's going on. And the first step, as Kai mentioned, is visualization. So typical example is doing some condition monitoring, measuring the frequency. And then try at level 4 to understand why that is happening. Usually we use dashboards, KPIs, so that you understand, for example, how losses in availability contribute to the loss of OEE, the overall equipment efficiency. That's understanding, but not predictive. So the next step is really to have a model, and you can either use simulation or artificial intelligence, so data analytics, to do predictions, yeah, failure prediction. So to be able to understand and have a prediction when the motor, the pump fails. Yeah, and we have some good examples to use artificial intelligence for that purpose. And the last step, I haven't seen that in full detail, but just an example in the self-optimizing system, the autonomous system. You won't find that for a complete plant for maintenance, but there are areas where you find, for example, lubrication control based on the temperature measurement. So having measurements in your machines and then adjusting the flow of the lubrication oil according to the temperature. Okay, that's one example showing the different levels and the technology and the issues and benefits. At the end, you have a set of measures and you have to decide how to align this measure. And very often you find an interaction between the different measures. So we try to sketch and illustrate the measures. On the left hand, you see the goals, yeah, on then the different stages. And you see that we have to go from stage 2 to stage 3 to stage. So you have to go through the stages. And as Kai already said, it doesn't make sense to think about artificial intelligence if you don't have connectivity in your plant. And what you see here is the value, yeah, P, and the costs, yeah, and the time that is needed to implement that. So that gives you the full picture of your initiative, your project, to decide what to do when, and on the other hand, do economic calculation for the plant. I'd like to emphasize that our project, and Kai already mentioned, they have run a number of projects, have a return time of usually 1 year. But very often we have to deal with measures on level 2, stage 2 or 3. So basic implementation, bringing connectivity, creating visibility. Yeah, these are the quick wins very often. Okay, but it's not all about technology. It's already Kai mentioned. It's how to implement this. And here are a few lessons learned, and I think we should discuss it and together. The first step, and I think we emphasize that it's not focusing on technology first, but focusing on the added value, really identifying and then thinking about the appropriate technology. So not starting with fancy stuff and at the end realizing that there's no business case, but really starting with the needs of the plant, the added value, and then think about the technology. Digitalization of the process industry means automation of business. I call it automation of business process. I showed the business process, and whatever we do should create added value in this business process. So at the end, we want to have a fully automated business process. So that's the reason why we call it automation of business processes. What's definitely needed is ownership for the digital assets. So somebody has to bridge the link between the domain know-how and digitalization. So somebody has to take care on that and manage that process. And it's at the end the change process. Yeah, introducing new technology always changes the way people have to act, how they work in their processes. So it's every digitalization process is a classical change project. Yeah, so change management competencies are as important as technology. So Kai, would you like
maybe
to
add to this? What we have seen in the last or in the current projects is that what Willem said is the change is mainly that the business process or the work process changed. When we introduce new technologies, people need to accept that to gain the value we have initially calculated. So now we extend our methodology to a parallel track at the same time, while we address the competency, the acceptance, and the skill needs from the plant, so that we do both the implementation of technical measurements and the implementation, for instance, for training or for other measures to increase technology acceptance, so that it's two streams in parallel. Because we see that as mission critical to really gain the values we've calculated and we have promised. So that was a rough overview. We're very happy to discuss and to interact with you on your ideas and your comments.
Thanks for
listening.
Thank you very much. Thanks for listening. We are looking forward to answering your questions.